Hello students, so let's try to solve one more problem from IIT-JAM 2023, and this problem is again from special theory of relativity. And this is very nice problem. So there is a detector and which will be broken into two particles whose rest mass is m and 0.5 m, and both are moving in opposite direction. So first the mass whose the particle whose mass is rest mass is m is moving with the speed c upon root 13, and this is moving with the speed c upon 2. And what we have to do, we have to calculate the rest mass of detector. So let us assume rest mass of detector is m. So obviously we have to use conservation of energy, but before using the conservation of energy, what we have to do, we have to check whether this detector is moving or not. So we have to find the momentum. If it is moving, then obviously we have to take the complete relativistic energy, and if it is not moving, then rest mass energy is the mass of detector. So obviously detector should not move because it is let's see what is this number says. Okay, so the momentum P of the detector is given by m into c upon root 13, 1 minus 1 upon 13 root under minus 0.5 into 0.5 m into c by 2 root under 1 minus 1 upon 4. So this should be our momentum, and when we will calculate it, this value is equal to mc upon root 12 minus, and this value is equal to m upon, so if we will calculate, so that value is equal to, so this value is mc upon 4 into root 3 by 2. So that value is equal to basically mc upon root 12 minus mc upon 2 root 3. And yes, we can write this mc upon 12 is equal to 2 root 3. So this value is equal to, so if we can take this particular value, so this value is equal to mc upon 2 root 3 minus mc upon 2 root 3, that value is 0. So yes, the momentum of this detector is 0. So that means this detector will remain at rest. So now we have seen that this detector is rest because momentum is 0, and the complete momentum after this particular explosion is 0. So this will be at rest. Now we have to go for conservation of energy. So when we will go for conservation of energy, the initial energy is nothing but the rest mass energy of detector. So this can be given by mc square, and that will be equal to relativistic mass of first particle, so that is m and root under 1 minus 1 upon 13, and c square is there, plus 0.5 into 0.5 m into c square upon root under 1 minus 1 upon 4. So this value is equal to 13 upon 12 mc square plus, and this value is equal to, you can have mc square by 2, and this value is root 3 into 2 is there. So this value is cancel out. So this value is equivalent to root under 13 by 12 mc square, and this value is mc square upon root 3. So when we will calculate this particular number, this number will come to approximately 1.6 mc square. So yes, we can compare it. Mc square is equal to 1.6 mc square. So m is approximately 1.6 m. So F value is equal to 1.6. So this is quite simple thing, but yes, you have to always try to find, you have to always use first conservation of momentum and check what is the actual momentum before the collision and after the collision. And after then you can use the conservation of energy. Okay, thank you.